All right, this is the at-home, first section for at-home on 3.2. Or I'm sorry, I said at-home, at school for 3.2. You got page 216, 21 to 39 ons. And again, Friday, we have a 3.1 and 3.2 quiz, which you'll probably be taking on Canvas, I believe. So we're going to be doing logarithms in this one, a little more on the log side. So this is what we talked about in the first video. This is the exponential equation, y equals 2 to the x. 2 is called the base, x is the exponent. And then this is equivalent to this in log form because base stays base, the other two place switcheroo that you did on your homework. This 2 is the 2 in the base of log, and then the x and the y switch sides. So what we're going to talk about today is we're going to talk about that this is the inverse of both of these because the x and the y have been flip-flopped. So I'm going to graph this and this on this same graph and show you what happens. So I'm going to put this one in red right here. And I'm going to plug -1 in there, which is 2 to the -1. And we talked about this in the other function. That puts 1 over 2 to the first, or a half here. So at -1, I'm at a half. You plug 0 in. Any number to a 0 power is 1, so that goes through 1. I plug 1 in there. That's 2 to the first, which is 2. So 1, 2. I plug 2 in here, and 2 squared, that's going to give me 4. So I go to 2 and I come up to 4, and this graph goes like this. So just like the 3 to the x power that I did in the notes, the domain for this one is -infinity to infinity because it goes left to right forever, and the range is above 0 and goes to infinity. So this is the horizontal asymptote. So there's a horizontal asymptote, which is the x-axis, y equals 0. So when I flip this over, if you hopefully you remember about inverses, the domain switches with this range. So the domain is 0 to infinity, and the range is -infinity to infinity. And I guess I'm going to change this to green. Should have used these for green. And so if you also remember, the inverses flip-flop these. So if x is a half, I'm getting that from right here, a half, y is -1. So I go to half, and I go to -1, and I put a dot right there. I got 0, 1, so that flip-flops to 1, 0. So this goes through 1, 0. 1, 2 flip-flops to 2, 1. So this goes through 2 and 1. And then 2, 4 flip-flops to 4 and 2. So I go out to 4 and go up to 2, and this graph is looking like this. And this graph will not touch the y-axis. So something we need to know is logarithms have a vertical axis. That is the y-axis, or x equals 0. In other words, logarithms can never have a value of 0 or negative. It does not work if you have the log, and if this number right here is 0 or negative, it always has to be greater than 0, or it does not work. You need to know that. So if you look, that's what this is an exponential function. This is what a log function looks like, and it goes down forever. So we're going to come over here, and we're going to look at the common log. This is the same properties I had it from before. Common log is when this is log base 10, and this is on your calculator, and it is simply the log button. So you're going to take your calculator, and you're going to hit the log button, which is in your calculators right to the left of the 7. So if I hit log button, and it gives me a blank there. So when you hit log, I'm going to type in 1 divided by 500 on my calculator, and that gives me -2.6989700004, and that's going to round to 3 decimal places. So this is going to be -2.699. And then I do the same thing on this number 24. I hit the log button to the left of 7, and I type in 96.75, and I hit enter, and that's that rounds to 1.986. So you can try that on your calculator, make sure you get the right thing. Now this, using the properties log, there are two ways to do this. So if I'm doing 26, if you do not have well, actually I can use these things up here. So if you look at this function right here that we did the other day, as long as your log base A of A matches up, the exponent's the answer. So do you see that log base N and N match up? So this answer is 2. If I look at this one, 5 log base 5 of 3. If you look at this one, if a log, where is it? Here it is right here, this one. We're looking at this one. If the base of the exponent matches up the log of the base, if these two numbers are the same, whatever that number is, there's the answer, whatever that number is. If you look here, that's where the 3 is. So that answer is 3. When you get up here, these say use 1 to 1. So if you look, this has log base 2 and log base 2. So that means that you can drop off the thing that's the same. So if this number, x minus 3, has to be the same as 9, so all you do is say x minus 3 equals 9. You add the 3 over, and x equals 12 would be how you solve that on a 1 to 1. Here you get x squared plus 6x equals 27 by dropping the common log off. And then you'd have to do a quadratic equation. So I'm going to do that real quick. So 32, you drop off the log, and you would have x squared plus 6x equals 27. You'd have to subtract 27 over. You got to get quadratics equal to 0. Now you use quadratic formula, or you can do your t-chart. 1 times negative 27 is negative 27. And I want a positive 6, so I believe 9 times negative 3 is negative 27 and 6. So this is x plus 9 and x minus 3. So this answer looks like it's going to have x can be negative 9 or x can be positive 3. Now when you get a negative answer, you got to make sure you don't get a negative in here. If you do, it doesn't work. So negative 9 squared is 81. And 6 times negative 9 is negative 54. And if you take 81 minus 54, you get 27, and it works. So these both work. So if this would have been a negative, that wouldn't work. If you try 3, you get 9 and 18. That is also 27. Okay, coming over here to number 34, I'm only going to do this 34, and I'm going to do it like I did the one before. I'm going to make a t-chart. So y equals 5 to the x, which means this is going to be 1 over 5, because you take a negative down to the bottom. So at negative 1, you're at 1/5, just above x. Plug in 0, anything to the 0 powers 1. So it goes through 0, 1 again. Plug in 1, 5 to the first is 5. So it comes up here to 5, and you plug 2 in, you get 25, and I'm not going to go that high. So this graph is going like this. And remember, you are not going to touch the x-axis. Okay, so that would be that graph. Now, if I want to do the y equals the log base 5 of this function, okay, you can just take these ordered pairs and flip-flop them. So 1/5 is going to give you out negative 1. I'm going to do these in red. So that means that 1/5, I'm at negative 1. We'll call that negative 1 right there. And 0, 1 means 1, 0 again. It's going to go through here. And then you're going to have 5, 1. So you're going to come out here to 5 and go up to 1. And then way out at 25 at 2, but I'm not going to go out that far. So this would be, oops, went a little too steep there. This would be your log function. Okay. All right. And then down here, you're supposed to do these problems and graph them. Now, you can graph these on your graphing calculator, and I'm going to show you on the graphing calculator now where you can find the log base of any number. So I'm going to get the picture screen over here. And I'm going to show you, I guess I need to move it over so I can see the actual problem. All right, I'm going to put 37 in there. Notice there's no parentheses. I'm going to do 38. Sorry, there are parentheses on 38, but not on 40. So I'm going to get my calculator here. I'm going to zoom in a little more. Okay. All right, so I'm going to hit my y equals button. Okay, I'm going to clear that off and clear this off. All right, so I'm going to type in number 38 here, log base 3 of x minus 1. So you're going to hit the math button that's under alpha. You hit math, and if you arrow up or down, you're eventually going to get there to that capital A, which says log base, and you're going to hit that. You're going to enter that. So that number 38 says log base 3, so I hit a 3 here, and I arrow over, and that's going to be x minus 1 going in the parentheses. So that's x minus 1 in the parentheses there. So that's my graph. Now on the bottom one, the x, even though in problem 3040 the x isn't in parentheses, you have to put it in parentheses. So when you type in 37, your x will be in the parentheses, and then you got to go to the right and do like I'm doing right now and put plus 2 there. But we don't want that there on this problem. I'm going to hit graph, and here comes my log. Now, do you notice that that looks like it stops? Well, this doesn't stop. So if you look at the x minus 1 in the function, that's a horizontal shift right 1. So remember the y-axis is the normal vertical asymptote here. But now, since there's a minus 1 on the problem, that's a horizontal shift right 1. Now 1 will not work for an answer. So even though this graph looks like it stops, it actually goes down beside the 1 forever. It never touches the 1, but it continues to go down forever. So you got to make sure that you notice that. So if I hit my table, just to show you, now remember, 1 is my vertical asymptote. Notice that's the first error. And then it says 2 is 0. Well, if I put a whole bunch of little decimals in there, and I'm going to show you this, if you hit second table set or second window, and if I go by 0.1s here, I hit 0.1 for the table change, and hit enter, and then I show my table. Oops, I got to get back down to where, remember, 1 is a vertical asymptote. Actually, it'd be faster if I did my table set and started at 1, and then go to table. So if you look, there's still an error, but you see here, these are negative values. Now, if I went to 1.01 in here, that's going to be even less of a negative value. 1.000001 will be even more of a negative value. It goes on down forever. Okay, so that is your homework, and I hope you do a good job on it. And I will see you guys next time in class. Good luck on those problems that I highlighted for your homework there.